Hello, we have now made it to the end of our unit on trigonometric identities. So today's video is to make sure you are clear on what all was in this unit, and then to kind of start back from the beginning to put it all together. So we'll spend a couple of days putting it all together before we have our test, quote unquote test. Okay, so obviously things are going to look much different than the way they have before. I probably won't even give you the same test as what I've already had planned, but I don't know, so that is up in the air. But what I do know is that we can certainly get ready for it in whatever form or fashion I'm gonna present that to you. Most everybody did. The ones that I've gotten so far, I've only gotten about half the class. I record these at night, by the way, so I haven't gotten everybody's yet. Quiz from yesterday, but I just wanted to remind you, quiz 8, this one right here, is the one that you just did with the virtual learning. Okay, so I was just trying to rack my brain and try to remember. You should have these quizzes back. I certainly hope I gave them back, but now that I'm thinking about it, a lot of students were absent for this one. A lot of you were absent for number 6, so I don't know that I'm pretty positive that I never gave that one back, and I may not have given 7 back either, because of absences. But nonetheless, you should know kind of in the grade book anyway, based on how you did. So, whether you had a pretty good idea or not. I would say of all the things, you guys kind of struggled with this the most. I mean, it is naturally the hardest one. 7 and 8 have formulas that you just have to memorize and plug in. So I think y'all are probably okay with that. So today's video, we're going to really just focus on this stuff right here. Okay. Now you should have your flashcards, so you have a little bit of an advantage with this digital learning, and I'm totally fine with that and understand it and embrace it. And I just hope you're getting something out of these videos and are feeling like your brain is at work a little bit when it comes to math. I know that it's not going to be exactly ideal like what it would be in the classroom, but so we will go forth. I am going to put this up. So this is what I'm going to ask you to do today. You have nothing to submit today. Okay, so I would like for you to pause the video right now and try to work problems A through K. Now notice we're omitting E and H, and that's just because they're a little more complicated than what we've kind of prepped and prepared for. So what you're going to do is you're going to work these problems here, and then you're going to find the answers over here. And then the answer matches up with the word. So if you think number 1 equaled, it doesn't, but if it did equal that, then you would put the word O right here in that blank, if that makes sense. So it's kind of a self-check worksheet, okay? Or you don't even have to do that. You can just simply work the problems. But what you're working are these right here, okay? So you're working A through K, and you're omitting E and H as seen on the screen. So if you'll go ahead and pause it, work those, come back to this video later to check. What I'm about to do now is I'm about to work through them, okay? Just so that you can have these. But again, you don't have to submit anything to me. I felt like the biggest thing that you might want to do at this point is to, oh, I don't know what I just did there. Is to kind of check yourself, okay? All right, so I'm blowing this thing up. Let's see if we can make it work. Okay, so if you remember back to this stuff, we want to break down everything as much as we can into the building blocks of trig, which are sine and cosine, okay? So we're going to try to break down, now we're going to leave sine of x because it's good. We're going to leave cosine of x, and we're going to change cotangent to cosine x over sine of x. Okay, I know I'm not going to have enough room for these, but that's okay. Maybe we'll go with it, and then I can go down and we'll make it work. All right, so the first reason I know that I need more room is because do y'all see that like nothing crosses out? Okay, so we're going to be left with sine x plus, we're going to put these two together. We're going to multiply them, so that's going to be cosine squared x over sine x. Now that looks like we're getting somewhere, but it's not all the way done because it's not, that doesn't look very simplified. So what we need to do is we need to get these two fractions together. So we need to get a common denominator. Starting off kind of tough with this one. So our common denominator is going to be sine, which means we don't have to do anything to this fraction. That one's good to go. So I'm going to leave that one. And I'm going to times this one by sine of x. Okay, and so now for this fraction, I'm going to have sine squared x, because it's sine times sine, plus cosine squared x. And then hopefully that looks like something. So this right here is a Pythagorean identity, and it equals 1. And now we're getting places. So now we can replace that Pythagorean identity with 1, and then 1 over sine x equals cosecant x, and we should be done. All right, I just took up a lot of space for that one problem, my bad. Okay, let's see if I can zoom out. So now we know cosecant is the answer, which is, let's find it. Where are you? Here we are. All right, so A is binary. And if you don't know binary, then this riddle isn't really going to make sense, but that's okay. It's no big deal. I don't really care. I care less about the riddle and more about the problems. All right, let's get a different color, and let's do letter B. This one's not nearly as difficult. So, oops. So we're going to do, leave cosine as cosine. And we're going to change cosecant to 1 over sine. Now, you see nothing crosses out here or cancels out, so we're just going to put them together. And then that is cotangent. So that one was much easier. Okay, so cotangent, where are you? Here it is. So B is going to be system. Okay. All right, so let's see if I have enough room for C. I'm going to kind of start below it and see if I can work from there. Okay, so I don't know if y'all noticed this, but on C, the very first thing I want to do is I want to distribute, okay? So I'm going to go tangent of x times sine of x plus tangent of x cotangent times cotangent of x cosine of x. Now, I hope you noticed something pretty quickly. Do y'all see that these two right here are reciprocals? So they immediately cross out since we're multiplying, okay? So now we're left with, and I'm going to go ahead and change tangent to sine x over cosine x times sine x plus cosine x. And this basically turns into exactly like what A is. So A had to have a common denominator, and that's what we're going to do here as well. All right, I'm going to kind of go down this way. So sine squared x over cosine x plus cosine x over 1. And so then I'm going to get a common denominator of cosine x. And I'm going to times this fraction by cosine x. Okay, hopefully that's not, I hope we feel okay with that concept. We worked on it a pretty good bit. I think most of us are okay with it. And so then this right here again is, oops, wrong thing. My bad. All right, so that is an identity. So 1 over cosine x equals secant x. All right, let's go try to find secant. So it's here, strange. Okay. All right, so D, now I don't know if I left enough time here. But basically A and C both have the concept of getting a common denominator. Okay, so we really need to make sure that that's understood, because that is an important theme we have talked about in this class. Okay, with D, I hope y'all see this pretty quickly. Looks like an identity. All right, so I'm going to kind of refresh your memory off to the side. And we just talked about it over here. So the first identity for one of your Pythagorean identities is cosine squared x plus sine squared x equals 1. So we want to try to manipulate this formula that I just wrote down in navy blue to look like the one over here. So if I want it to look like the one in the problem, I need to subtract the sign. Okay? So if I subtract the sign, what am I now left with? So I'm left with cosine x equals 1 minus sine squared x. So now I can replace the cosine, this part here, with this part over here in this equation. Okay, so I'm going to replace 1 minus sine squared x with cosine squared x, since those are equivalent to each other. So I'm going to have secant squared x, I'm just going to bring that down for now, times, and then cosine squared x, because I'm replacing this 1 minus sine squared with what it's equivalent to, which is cosine squared. And now hopefully you remember that those are reciprocals of each other. If you don't remember it, you can just rewrite it. So secant is 1 over cosine squared times cosine squared. And so they will just cross out and you'll get 1. Remember, you can only cross out because they equal 1. Cosine squared divided by cosine squared is 1. You can only do that on multiplication and if they're above and below each other, either directly or diagonally. All right, so 1 is here. Thanks. All right, so now let's go on to E. Oh no, we're skipping E, I forgot. Okay, so let's go to F. F is one we did talk about, but it definitely is going to take some refreshing. Let's get some other colors. Okay. Oh, we've been using hot pink. Never mind. Okay, so what I want to refresh your memory with is DOS. If you remember, that's called difference of squares. So we're looking for these 3 things. The exponents need to be even, and the sign in between the terms needs to be positive. Listen to me, a negative. Okay, so then you're allowed to go like this. And essentially, when I explained this to y'all in class, I used this example. If y'all remember that. So that's kind of the same concept we're going with here. So with x squared, we just divide it by 2 to get x and x. So we're going to do the same thing with to the 4th. So it'll be cosine squared x, sine squared x, and sine squared x. And then notice what has to be true about the signs. One has to be positive and one has to be negative. Okay, I'm going to erase this just because I need room. But that's essentially difference of squares. Okay, and then one of these, this one right here, is the identity. So 1 times cosine squared, x minus sine squared x is just that. Because 1 times anything is itself. Or is that number itself. All right, so let's see if we see this answer over here. Because that is as far as you can go. All right, so let's go. F is no. I'll go back and tell you what E and H are if you would like to know. Okay, so then G is going to be worked very similarly. It's going to be similarly, to D. All right, so we're going to work G like using this concept again. Okay, so I want to try to get this first one to manipulate to look like the numerator. Okay, so I want to subtract the sine squared. So then I'm going to replace the 1 minus sine squared with cosine squared x. Okay, and so then I want to then subtract the cosine over, so I'm going to replace 1 minus cosine squared with sine squared. All right. I want to show that again just to make sure everybody's clear. So I want it to be manipulated, right? So that top one, the numerator, looks like that, so I'm going to replace it with this. And then I just do the same exact thing again for the denominator, but this time I subtract the cosine squared x. I can't actually subtract them because they're not like terms. So, and then now this equals something, and that's cotangent squared x. All right, there it is. So 1, am I on the right one? G, yeah. And then 1 can go here, and 1 can go there. Okay. All right, so, nothing has been too terribly difficult. We've really had common themes of common denominator and then manipulating the Pythagorean identity to be able to replace, okay? All right, now I think is going to be fairly straightforward. Let's see if we can make sense of it. So I'm going to leave cosine squared, and I'm going to rewrite tangent as sine squared x over cosine squared x. And then we can cross those out, so we're left with sine squared x. Not too bad. All right, so where is sine squared x? O. And what letter am I on? I'm on I. I don't know why that went away. Okay. Okay, so then let's work the next one. All right, so sine, I'm going to blow this up so I have room. I'm going to leave sine as sine, and I'm going to replace secant with 1 over cosine. And then I'm going to put these together. And just be really careful about that equals tangent, not tangent squared. Okay, because sometimes, like on the previous problem, you had to have the squared. On this one, you do not want the squared. So tan, we're trying to find tan x. Where are you? There it is, 5. All right. And then k is our last one. So k looks really complicated, but here's my suggestion, is don't get too wrapped up that k looks complicated, because it's actually really not. Just kind of pretend like the square root isn't there, okay? So we're going to simplify everything in the square root first, and then we'll worry about the squared in the end. So secant is going to be 1 over cosine squared x minus cosine squared x. And then notice right away, these are reciprocals. You might have even seen that to begin with. And so now, this is going to be, this is a concept that some of us struggled with. Do we put the 1 or do we not put the 1? Because there is a subtraction sign, we definitely have to put a 1. Okay? So if it were multiplication, you do not have to put it. And then we're going to go back again to this concept of the Pythagorean identity. The reason I know it's a Pythagorean identity, besides the fact that I've had a lot of practice in my life, is that it has a 1 and it has a squared. So I want to get this manipulated, so I'm going to subtract the cosine. So I'm going to replace this with sine squared x. And so now, do you see we have a square root and a squared? And what do they do to each other? Well, they cancel each other out. So the square root, that's really not good. The square root and the squared cancel each other out. So what are we left with? Plain sine. And I don't think we've had that before. We had sine squared, I believe, but not sine. All right, so NK is going 100. All right, so now it says, the binary system is fun, for with it strange things can be done, and 10, as you know, is 1 and n. This should be 10, I believe. Let's see. Where is 10? Oh, and 2, as you know. Sorry, it's a 2, not a 10. So this should be the word 2, and this should be the word n. So if you're interested, if you know binary, basically it's saying that you can rewrite the number 2 as a 1 and a 0, like an O, like the letter O, a 1 and a O. But don't you worry about that at all if that doesn't make sense. So that tells you if you want to be challenged and you want to try E and H, that'll tell you that this is the answer for E. And then where is N, excuse me. N is right here, is H. Okay, so if you want to challenge, you can certainly do that. I don't want to intimidate or overwhelm anyone, so I'm stopping there. All right, so that was a lot of me talking. I apologize, but I hope it does help kind of get things straight. And we will continue to review this and the sum and difference tomorrow on Friday. Awesome. Hope y'all are doing great. I miss you guys a lot.